In lesson 23, we're going to be introducing lines and slope. Now, a linear equation is what you call the equation of a line, and it can be written in this standard form, ax plus by equals c. You actually saw this in the last example in lesson 22. This is called the standard form of a linear equation. And the a has to be a number greater than 0. What that means is that these are integers usually. Now, in order to graph a line, you have to have at least 2 points. We saw the point method in the last section, and in this section, we're going to be looking at the intercept method and also the rise over run method, or slope-intercept form. So we're just going to continue to do the same thing, but I want to review what it looked like in the last section. There are just different ways to do it, so it's kind of good to be exposed to all of them. I'm going to quickly calculate with you using this equation that they gave us, the x and y values that are missing. We want to complete these points. Sometimes they're giving us x's, so we'll plug in for x and solve for the y. Sometimes they give us the y's, we'll plug in the y and solve for the x's. Here's the first one. If I plug in an x of 0, it's going to say 3 times 0 minus 2y equals 12. 3 times 0 is 0, so we get negative 2y equals 12. After dividing both sides by negative 2, we're going to get y is equal to negative 6. If we plug an x of 1 in, we'll get 3 times 1 minus 2y is equal to 12. That's 3 minus 2y is equal to 12. I'll subtract the 3 over, so we get negative 2y is equal to 9. And after dividing both sides by negative 2, we get y is equal to negative 9 halves, which we found earlier was negative 4.5 or negative 4.5. I wanted to go ahead and write that right here, and I'll put it just really sneaky in black right here, so I'll know where to find it on the graph. All right, now let's plug some y's in. If I plug in a y of 0, we're going to get 3x minus 2 times 0 equals 12. That's 3x, the 0 is gone, I'm not going to write down plus 0, equals 12. After dividing both sides by 3, we're going to get an x of 4. And one more. If we plug in a y of negative 3 into my original equation, 3x minus 2 times y, which we're plugging in a negative 3 for this time, equals 12. We get 3x plus 6 equals 12. When I move the 6 over to the other side, we're going to get 3x is equal to 6, and after dividing both sides by 3, we get x is equal to 2. We've got our 4 points. Let's plot them and graph it. This is just us reviewing the method that we learned in the last section. Go to where x is 0, go down to negative 6. Go to where x is 1, go down to negative 4.5. Now, right there. Go to 4, 0. Go to 2, negative 3. So cool how they'll always line up. And if they don't, you know you made an arithmetic error, so you can fix it. Now, this next method that we're going to look at is called the intercept method. The x-intercept is actually the point where the graph crosses the x-axis. And the y-intercept is the point where the graph crosses the y-axis. So no biggie there. There's not like a trick or anything. An x-intercept is where it crosses the x-axis. It's where it intersects it. Y-intercept, where it crosses the y-axis. Now, the cool thing about it, in order to find the x-intercept, we just let y equal 0 and find x. To find the y-intercept, you let x and find the y. That's all you've got to do. So really, we just need to build 2 points. I'm going to make a little table for us. This is the intercept method. I'm going to let x be 0 once and y be 0 once. And I'm going to finish those 2 points. These are the 2 intercepts, and that's all we need to do. Now let's do it. I'm going to use this equation that's provided, and I'm going to complete the 2 points. I'll do it in black. If I let x equal 0 in the original equation, it's 2 times 0 plus 3y equals 9. That goes away as a 0. We get 3y equals 9, or y equals 3 after dividing both sides by 3. Sorry, I didn't show that. All right, we've got one more point to complete. Oh, guys, I made an error. Let's fix it. That should have been a -9. Did anybody see that? Let's fix it really quick. That's going to make that a -9. So tell me what would be different. -9 divided by 3 would make that a -3. I just noticed that. I saw it. Okay, now let's plug in a y of 0 and solve for the x that goes with that. 2x plus 3y, which is now 0, equals -9. Not going to forget it again. That's 2x. 3 times 0 is just 0. I'm not going to write it down again. So I get -9. After dividing both sides by 2, we're going to get x is equal to -9 halves. And again, on the sneaky, we know that that's actually -4.5. All right, let's plot the 2 points. And this is the intercept method for graphing. 0, -3. -4.5, 0. You only need 2 points to graph. Now, what is the advantage of each one? For the intercept method, it's quite a bit shorter, isn't it? But the point method gives you a double check. If you find that one of your points is wrong, on the point method, you're going to notice that one of the points doesn't line up. With the intercept method, even though there's only 2, if you mess up on one of them, you still get a line. So it's a little harder to tell if you made a mistake. Now let's talk about slope real quick. And we'll calculate a few. Now the slope is actually the rise or fall of the line. And there's actually 2 special slopes as well. Let me draw them for you. If you have a line that has an upward tilt, that is going to denote a positive slope. And I mean as you read it from left to right, the way you read an English sentence. If it has a downward tilt, as you read it from left to right, that is going to show us a negative slope. So it's all about what it looks like as you're reading it from left to right, like an English sentence. If I'm reading it from left to right and it's going up, I associate up with positive. I associate going down from left to right, the way you read an English sentence, as negative slope. There are 2 special slopes as well. This is called a slope of 0. And this is called a slope of undefined. Those are the 4 types of slopes that we're going to see. Now, if you have a 0 slope, I like to think about it this way. I wish I could show you me. So I could like show it with my hands. Okay, so everybody understands that if the line is going up from left to right, it's got an upward tilt, it's positive. If you're going down the line, it's got a negative slope because it's got a downward tilt, and we associate going down with negative. Now, if the line doesn't go up or down as you're reading it from left to right, it just remains constant. That's a 0. And of course, if it goes up and down like this, that is undefined, and it has to do with a calculation that we're going to do in just a little bit. But I want to show you something kind of cool that I learned when I was a kid, and I still remember it. Drive a little car up the mountain. Well, I associate going up the mountain with positive. If I'm driving my little car down the mountain, that's a little Volkswagen Bug, by the way, okay? If I drive my car down the mountain, I associate that with negative. This one's a little harder to understand, but if you're driving your car on a road that doesn't have any lift, any drop to it, no hills, just stays exactly the same and straight, that's a 0 slope. It remains constant at 0. Now here's the one you're going to get. If you drive your car this way, see how it exploded? You're undefined. You just blew up. Doesn't work. No solution. Okay, that's how I learned it, and I think it's kind of cool. All right, I talked too long, so I'm going to start here on the next video.